Let's think about the implications of the Maxwell's equations here. Suppose I take a charge, Q, and I move it from there and back. Matter of fact, I'm going to oscillate back and forth in some sort of harmonic motion, simple harmonic motion. As it moves back and forth, consider a point P here. When the charge is first sitting there, and we'll assume it's positive charge for the sake of argument, the electric field is in that direction. That's the initial electric field. When it's over here, we'll just call it point 1, the electric field is now pointing in that direction. So my electric field changes. If I imagine that I have some sort of Gaussian surface right here, my electric field changes and therefore my electric flux changes. So charge moves, creating a change in the electric field at point P. If my electric field is changing, that means I have a change in the electric flux. If my electric flux is changing based upon this, that means that I have create a magnetic field. Now, the change in the electric field and thus the electric flux is not a constant change because I'm moving over here and then back and forth, back and forth. So there's some oscillating going on. So there's a change in the change in my electric field, therefore a change in the change of my electric flux, which means that there's a change in my magnetic field. The change in the magnetic field means that I have a change in the magnetic flux. If I have a change in the magnetic flux based upon Faraday-Lenz's law, that means I am creating an electric field. Because this is moving back and forth, not only is there a change in the electric field, but there's a change in the change. As a matter of fact, there's a change in the change in the change. So my change in the electric field causes a change in the electric flux, causes a change in the magnetic field, causing a change in the magnetic flux, causing a change in the electric field, and I'm basically cycling back around. Once I get the charge oscillating back and forth, creating this change in the electric field, that change in the electric field sort of takes over on its own, creating a magnetic field, which creates an electric field, which creates a magnetic field, creates an electric field, and so on. And this is how an electromagnetic wave is produced. Often abbreviated as just an EM wave. And so Maxwell realized this. Once this piece was added, Maxwell realized this and he thought, well, if this is producing an electromagnetic wave, is there a speed of an electromagnetic wave? And from that, he then calculated the speed of the electromagnetic wave. And that is the subject of another video.